Okay, we've got one last video for this section. We're actually going to put together everything we've learned in this section. Okay, so we've got this polynomial f of x equals negative x cubed minus 5x squared. And what we want to do is sketch a graph of it. So the graph's not going to be perfect, but we want to use everything we've known to kind of get an idea of it. Okay, so the degree here, the degree is the highest exponent, is 3. So from the last video, we know that that means at most it's going to have 3 real zeros and 2 turning points. Okay, now the end behavior, remember the leading term test, we look at this, and it's odd and negative. Okay, so that means it's going to look like this. Now, to get the y-intercept, you're always going to look for f of 0, because that's where it crosses the y-axis, and the x value of the y-axis is 0. So f of 0 here will be negative 0 cubed minus 5 times 0 squared. We get 0. So we know it's going to cross at the origin. Okay, now we want to find all the real zeros. So we're going to factor negative x cubed minus 5x squared. What we're really solving is when is this equal to 0? And we can pull out an x squared, and then we'd have negative x minus 5 equals 0. Well, that means that the 0, if we set x squared equal to 0, we would just get 0. And it has a multiplicity of 2, which means it's only going to touch there, not go through. Now, if we set negative x minus 5 equal to 0, we get negative x equals 5, so x equals negative 5. So we get another 0 at negative 5, and its multiplicity is 1, which means it will cross there. Okay, so we're going to plot the point negative 5. 1, 2, 3, 4, 5. Okay, and we know the end behavior that it's going up to the left and down to the right. So now the 2 blue dots we put are the only places it's going to cross the x-axis or touch. And we know at negative 5 it crosses through. So we're going to come down here, cross through at negative 5. We have to come back up here to 0, but we know it's only going to touch and bounce off, and then it's going down toward infinity. Okay, so there's a sketch of our polynomial.